What if Earth's most efficient tactical planner doesn't even have a brain? Prepare to witness a devastating biological exploit. Tokyo Railway Network design is a massive marvel of modern human engineering and urban planning. It took decades of complex mathematics to balance construction costs and daily transit route efficiency. Yet your species spent millions computing what one brainless organism solved in 26 hours. I am physically analyzing this subterranean transit node to understand this highly asymmetric biological advantage. Human researchers recently conducted an experiment using a simple, single-celled organism called slime mold. They placed physical oat flakes on a flat template representing the major Tokyo urban hubs. I have located a similar physical map in this sector and am scanning node distribution. The zombie population moves through these dark corridors with remarkable yet highly predictable systemic friction. When the slime mold was first introduced to the template, it expanded everywhere simultaneously outward. This is a brute force exploration protocol designed to flood the zone, mapping all resources. But expanding everywhere is highly inefficient and quickly consumes massive amounts of stored biological energy. The organism rapidly adapted as my thermal scans reveal it began retracting the redundant pathways. It physically reinforced only the most efficient structural connections between the highest value nutrient hubs. Within hours, the creeping mold had created a physical nutrient-sharing network, looking strangely familiar. It was mathematically identical to the human-designed Tokyo railway system, but built without brains. This is a decentralized biological algorithm, achieving optimal resource allocation entirely through local feedback loops. Observe this civilian specimen, who relies entirely on centralized instructions to navigate the transit network. The mold does not have a central planner, because every part of the organism decides. If a pathway is physically damaged, the surrounding tubes automatically widen to reroute the flow. This self-healing infrastructure completely eliminates the critical vulnerability of a centralized command-control system. I am currently overlaying the growth pattern onto the physical architecture of this underground station. Human engineers are now studying this exact brainless organism to design better modern structural systems. They use its biological algorithm to map out adaptive self-healing power grids for cities. The tactical applications for information warfare and adaptive internet routing protocols are immediately obvious now. By studying a simple mold, you unlock the ultimate blueprint for truly indestructible network design. The most resilient systems in nature never rely on a single vulnerable point of failure. They distribute the processing power across the entire physical structure of the growing network itself. Engineers finally realized that nature already optimized this complex survival problem millions of years ago. I'm extracting the structural data from this physical map to update our tactical models. It proves that sometimes the most complex engineering problems require the absolute simplest biological solutions. We often wrongly assume that intelligence and optimization require a central brain or massive computers. True systemic dominance actually comes from decentralized and highly autonomous physical adaptation at the edges. The zombies around me remain completely unaware of the strategic masterclass operating beneath their feet. Next time you ride a train or use the internet, always remember the humble mold. Its silent, creeping logic is exactly what keeps the modern human world functioning so smoothly. I have gathered sufficient field data, and the algorithmic superiority of this organism is verified. We will integrate this decentralized routing protocol into our own planetary supply chain logistics network. The natural world is full of hidden strategies waiting to be physically discovered and exploited. How would you apply this decentralized, self-healing algorithm to your own competitive systems today? Submit your tactical proposals in the comments below, because this concludes my current field observation.